Have you ever watched a shot by LeBron James or Kobe Bryant and wondered what physics is happening behind the scenes? What if I told you that every jump shot follows the exact same equations you learned in AP Physics and Mechanics? Today, we're going to analyze basketball shots using projectile motion, calculate the maximum height and velocity of the ball, and then apply the same physics to an archer launching an arrow from the bow. Let's see how physics connects to completely different sports. When a basketball leaves a player's hands, it becomes a projectile. A projectile is any object moving through the air while gravity is the only significant force acting on it. The ball's motion can be separated into 2 parts, the horizontal motion and the vertical motion. The horizontal velocity stays constant. The vertical velocity changes because gravity continuously accelerates the ball downwards at 9.8 meters per second squared. We'll use AP Physics and Mechanics to determine the maximum height and the final velocity when the ball reaches the basket. Let's start with LeBron James in his prime. For a model Wilson, release height is 2.3 meters, launch speed 8.5 meters per second, launch angle is 52 degrees. First, we break down the velocity. The vertical component is v sub y equals v times sine theta. Plugging the numbers gives us 6.7 meters per second. At the very top of the shot, the vertical velocity becomes 0. Using the kinematics equation, v squared equals v0 squared plus 2a delta y. It'll solve for the maximum height. The basketball reaches approximately 4.59 meters. That's over 15 feet above the floor. Maximum height is 4.59 meters. Next, let's determine how fast the ball is moving when it reaches the hoop. Using another kinematics equation, we can find the vertical velocity of the basket. The vertical component is approximately negative 5.49 meters per second, meaning the ball is traveling downwards. Combining this with the horizontal velocity using the Pythagorean theorem gives us 7.58 meters per second. So the final velocity is 7.58 meters per second. Now let's compare that to Kobe Bryant. Also, release height is 2.1 meters, launch speed is 8 meters per second, and launch angle is 50 degrees. Using the same process, we'll calculate the vertical velocity component and solve for the maximum height. Kobe's shot reaches 4.02 meters, which the maximum height is 4.02 meters. Repeating the kinematic analysis for the basket position gives the final speed of 6.75 meters per second. LeBron's shot has a slightly higher arc and greater final speed because of his higher release point and launch speed. Now let's test whether these same equations work for a completely different sport. Imagine an archer launching an arrow. An archer fires an arrow at 60 meters per second, 40 degrees above the horizontal. Find the time to get the maximum height, total flight time, and range. First, split the velocity into horizontal and vertical components. Horizontal velocity is 45.96 meters per second, and the vertical velocity is 38.57 meters per second. At the highest point, the vertical velocity is 0. Solving gives us 3.94 seconds. Using kinematics equation for displacement, the arrow reaches 75.9 meters. That's about the height of a 25-story building. And now for the total flight time, because the arrow lands at the same elevation where it started, total time equals twice the upward travel time, to get 7.88 seconds. Finally, the range equals horizontal velocity multiplied by the total flight time for the horizontal range, and this gives us the arrow travels 362 meters. Whether it's a three-pointer from LeBron James, a fadeaway from Kobe Bryant, or an arrow launched from a bow, the same AP Physics principles apply. By using kinematics and projectile motion, we can predict how high an object travels, how long it stays in the air, how fast it moves, and where it will land. Physics isn't just something we study in a classroom. It's happening every time an athlete takes a shot, throws a ball, or launches an arrow. If you've enjoyed this video and want to see more physics applied to sports, engineering, and real-world problems, consider subscribing and sharing this project. Thanks for watching. Peace out.